Okay.
So, well, good morning or good afternoon to you all, and really thankful for those of you who have agreed to join this call. This is a meeting that was suggested, in fact, by Moez, but that found echoes by a number of colleagues here from the Arab Risk Analysis Network. Basically, we know that there was a multiplication of assessments in relation to COVID-19, the virus, and its impact on food and food safety. And one of the assessments was conducted by an agency that we've been collaborating with through the Arab Food Safety Initiative for Trade Facilitation, SAFE. And that is ANSES, the French Food Safety Agency. And Dr. Moez, Sanaa from ANSES has kindly agreed to be with us today and actually to share with us the outputs of that evaluation and to answer any questions that we may have. So thankful to you all for joining. I acknowledge the participation of Dr. Hossein Mansour, the CEO of the National Food Safety Agency in Egypt, and our colleagues from a number of countries, Jordan, Tunisia, Morocco, being present. So thank you and welcome to you all. Moez, I'm going to give you the floor.
Okay, I try to share the presentation. So I have some problem today with my internet connection and type item. I am disconnected. So I will try to update you about the different scientific opinions that we perform in ANSES during the last month. I will make one break during my presentation, so I give you the opportunity to ask questions. So I will deal with two parts, one for domestic animal and the second one with the food safety. So when I finish the potential risk from domestic animal, I will make a stop and we'll continue after. So we have almost 1 hour. I try to not use all the time to leave room for questions. Okay, what's this? Okay, so we are, this is what different authors expect several years ago. We are the new risk environment. The crisis that you are experiencing today is a good example of what we call the black swan phenomena, which is you have a very low probability event with high impact. So that is very hard to detect. And you have the other effect known by butterfly effects, a small thing that happen in a small seafood market in China. It has a worldwide effect, and it stopped all the economy all over the world. And we are in a situation with high uncertainty. This is hard to predict, and there's fast changing. What you are telling to you today, it can be modified tomorrow by new information, new scientific data. So this is something very new, and I think this, what you call them, this systematic risk, we will modify our way to think and how we will deal with risk for the next decades. So the thing started in 8th of January with the cases that we observed in China, and at the end of February we start seeing cases outside of China. But I hear today that in the United States they realized today that there is some information that some cases in the US occurred between 16 and 17 of February. So the move to the US was not after the end of February, but apparently some cases with no connection with the travel has been observed in recognized today in US, the cases between 17 and 18 of February. Okay. So we are a lot of surprises coming. After the current situation now, it is everywhere. So you see, it is everywhere. And as an epidemiologist, as I realized that with this crisis, we realize that we are not doing epidemiology in the same way. The metrics that are used to follow the situation, we see a lot of metrics: number of cases, number of deaths, number of hospitalized. Sometimes we just giving numbers, sometimes we are giving ratio, but there is some work to do on how to present in the more rational way the course of one epidemic when it is global. So a lot of communication about the number of cases we can discuss it in after the crisis, and how we should communicate the number of cases. So in ANSES, so we know that we received in beginning of March a question from the government with the context that you know very well. And at this time, the main route of transmission is between humans. And our government said, okay, what about domestic animals, and what about the transmission of the virus through food? So it is a question and that arrived at the beginning of the week, and we have only 3 days to answer to this question. So very rapid risk assessment. I put in this page the different, so the first scientific opinion was published in March 11, followed by another one in March 19 about regular physical activity during the confinement situation. Recommendation on food, shopping, and cleaning, exposure to virus in the workplace, be aware of poisoning linked to disinfection and other risk situations. We work as well in sewage and sludge, because we found in non-treated water place of the virus. It's not if it is active or not, but in
Moez,
update.
Okay, yes. We lost you for a second there, so if you can repeat.
Yeah,
3 seconds.
I know. Yeah, give me a sign when there is a problem. I cannot explain what happened today, but all my meetings I have a lot of disconnection during my my presentation. Okay, sorry for that. Okay, so we did a rapid scientific assessment on the potential role of domestic animals, mainly livestock animals, and the spread of the SARS, their role in the spread of the virus, and the potential role of food in virus transmission. Okay, how we organize our rapid risk assessment, we call it GQ in French, that means it's emergent working group. So we work remotely, so by telephone and teleconference. This is the name of the expert, and the first list is about the external expert, and the second list are the internal experts in EFSA. So it is a common work that we did with the unit of animal health and the unit of food safety. Okay, so the question number one, let's start with the question number one. So I don't know if you read afresh what is coronavirus, is RNA enveloped viruses. There is a different family or different genera, alpha, beta, gamma, and delta. Alpha are known to give mild respiratory infection, but the one that are of interest are the beta coronavirus that are responsible for cases in humans. One of them is SARS-CoV, the one of the epidemic of 2002 and 2003. The virus disappeared. There is no cases, no in circulation of SARS-CoV-2 today. And MERS-CoV is the one that emerged in Saudi Arabia in 2012. And this virus continued to circulate to circulate. It's not the same case as SARS-CoV. And now we have the SARS-CoV-2. So it's very important to have an idea about the structure. So you have this virus with envelope. You see the envelope. And one piece of the envelope is what they call them the spike protein. It's very important. It's very helpful to understand how the virus could adapt to other species. And it will be used to understand why we can observe transmission through oral transmission or respiratory transmission. So they are very important because they will be used to in the mechanism of the entry of the virus in the host cell. Okay, so so we are interested by the beta coronavirus, and within the beta coronavirus we have 5 subgenera, and the SARS-CoV-2 is part of the SARS-CoV-2 subgenera. And what is interesting, that's no virus belonging to SARS-CoV-2 subgroup had been detected in domestic animals. This is one of the evidence that we use to say there is no transmission to domestic animals for the moment. And there's no direct genetic link between SARS-CoV-2 beta coronavirus strains isolated from domestic animals. And you can see it here. I don't know if you see it before. This what we call the phylogenetic tree. You see here we have the different subgenera of beta coronavirus, and we are interested by SARS-CoV. And we see that we have 3 clades. And it's close to some virus that
you missed a little bit, Moez.
Yeah, some yeah. So this is show that the SARS-CoV-2 2019 is in one specific clade, and we see there is a distance with the other one, like SARS-CoV is here very, very far away from the one that we observe today, and it is closer to some strains that we isolate from bats. And the more interesting is, this one we see it before. So for the, just 1 minute, yeah, this is when you, because there is a lot of analysis using the sequencing of the genome of the RNA of the coronavirus, and what we can see that we have almost 97% of genomic identity between SARS-CoV-2 and rat, we call it rat G13, the one isolated in Yunnan 2013 from bats. So this is that's why we say the origin of this virus is coming from bats. So so the first question for us, we have SARS-CoV-2 is a new virus that seems to be, and you have the confirmation, it's very adapted to human, because when you see the transmission, the efficacy of the transmission, that means this virus, like the human being, and is well installed and like to be transmitted from one human to another one. So the question is that why we observe a new virus is not only mutation, it's mutation and recombination. When you have the virus, you can have 2 viruses from 2 different origins, and they can recombinate. And what you are saying is mainly about recombination rather than mutation of one single strain. So the origin is a bat, with or without intermediate host, because we we have this hypothesis that the pangolin perhaps is play a role on the recombination of the virus, but we are not very sure. So crossing the species barrier selection need several events. And a lot of adaptation to a new host species. So saying today that this virus will be adapted fastly to domestic animal is something very, very difficult. You see what I mean? That because here, when you see the time needed for SARS-CoV-2 to recombinate with other animal species and to adapt to other species, it will take a lot. It will take time. So for the moment, the arguments today, it will not be very effective, this virus, if domestic animals will be exposed to this virus. So, the other argument is very, very adapted to a human being because the R0 is higher than 1. That means it's very, very, very infectious and very contagious. Okay, so the second argument is for the crossing the species barrier is to do some experimental studies. And the experimental studies was done only for animals that have the ACE2 receptor. What is the ACE receptor? Remember this S protein, the spike protein, need a receptor ACE2 to enter to the cell. I will show you the functioning. So you have this virus need a sort. It has the key. This is the S, and here the door represented by ACE2 receptor. So if you have the key for the doors, you can open the door, and the virus will enter to the cell. This is needed for the pathogenicity of the virus. So those ACE2 receptor we can found it in different animals, not only in humans. So that's why they perform different experimental studies using animals known to have the ACE2 receptors. And this is what we have from the experimental studies that give you an example. 40-day-old pigs, chicken, and 4-week-old ducks are not susceptible because when we expose them to this virus, we didn't observe any infection or reaction or clinical signs following the exposure. However, for dog 3-month-olds, in certain conditions we can observe infection, but the conclusion was that are not very receptive to this virus. For the cats, we have the proof today they are receptive, and young animals appear more susceptible.
Moez.
That are used, ferrets and hamster seems to be as well receptive to the virus.
Moez?
So, yes.
An intervention briefly, if you
Yes.
don't mind. Sorry.
Yes.
Is it okay to intervene or?
Yeah, go ahead, please.
Okay, dogs. There was 2 studies from the OIE.
I will come to them.
Okay.
I will come
Thank
to
you.
them because for the moment I am only showing the experimental studies, and we have the natural infected animals. We will see them after. So for the moment, this is experiment. We expose animals to the high doses of viruses to see if they can be infected. Of course, it's not representative of the natural condition because we are exposing them to high doses. You see, you are just looking if they can be infected or not. So the researcher, they put themselves at high chance to observe the infection. That's why they expose them to high doses. So it can be, so what we know, some animals can be infected, but for the moment we don't have the reverse. If the domestic animals are infected, can they transmit it to animals? It is another question. Now, let's go to your question and see the cases of infection observed in animals. Here, there is no experimentation. And we have 4 studies or 4 events. The first one is about cases, 2 dogs and 1 cat in Hong Kong. The first one that you mentioned that was declared, notified to OIE. And you see it's an old dog. There is no clinical signs. We observe 5 samples of RT-PCR positive, no virus isolation, and the animal became negative, but the serology was positive, and the animal died on 16th of March 2020. We cannot attribute this death to the infection, I think, because it is an old animal. That's why. And apparently, because this animal was isolated from his own owner, so it's maybe it's natural death. Is not. It cannot be linked to the infection. And we have another second dog case in Hong Kong, observed in March. Is a 2 years old dog, no clinical signs, RT-PCR positive. And this time we isolate the virus and the serology was positive. So something new. And another cat, no clinical signs, but RT-PCR positive. As for the 31st of March 20, there was another study in Hong Kong, a cohort of 27 dogs and 15 cats in close contact with patients with COVID-19 and quarantined by the Hong Kong authorities, was monitored. Only 2 dogs and 1 cat tested positive in RT-PCR. This is another information that we get recently. We have after that the case of Belgium cat. The Belgium cat now is becoming different because we have RT-PCR positive in feces samples, and the virus was isolated from the feces, and we have clinical signs. It's something new, and we have the same thing with the tiger in the at New York Zoo. Okay, so we have another study that was done in one city. The work involved cat sera collection before and after the onset of the outbreak. They observed almost 15% of positive cats. It was a test ELISA indirect specific to receptor binding domain of spike protein. And you see some titers are high, and the one that was exposed to human cases shows a high titer of serology. However, the RT-PCR was negative. Okay, another observation here in France. We have a cohort of animals that were in close contact with veterinary students. 2 of the owners tested positive for COVID-19, while 11 others showed symptoms highly suggestive of COVID-19 infection. And for this small sample, neither RT-PCR nor serology was positive. All of them was negative. Another study by the firm IDEX in different countries involving almost 4,000 samples from horses, cats, dogs in the United States. in different areas, and in South Korea, all the RT-PCR conducted was negative. Okay, so in conclusion, the experts of our group point out that rare cases of contamination and or infection of pets with SARS-CoV-2, sorry for the reverse, have been reported so far. The contamination and infection of those animals remain sporadic, and the investigated cases are in favor of human to animal transmission for the moment. This is, I think we cannot discuss it. We can say there is a possibility of transmission from human to animal. However, in the other way, we cannot say if one animal is contaminated. We don't have evidence of the other way, transmission from animal to human. There is a difficulty for the interpretation of all those studies because for the moment, the majority of the tests were based on RT-PCR. Yeah, we should explain that RT-PCR, it is not a proof of the infectivity of the virus. This is very important to have in mind. And it can be, it is a trace of the virus, but we are not sure of its infectivity. So the animal is affected, and in some cases we cannot say it is a real infection, but passive contamination cannot be excluded. So we in some of the observed cases, is it just contamination, external contamination of animal, but for cats we see the infection. So this is our first conclusion. So the passage of SARS-CoV-2 from humans to other animal species currently seems unlikely. That was our first conclusion in the 9th of March. But despite the new evidence, our experts remain prudent and say it seems unlikely, but at least for cats, we can say there is transmission from human to animal. Okay, so I finished this part. If you have any question for animals, please go ahead.
I think, thank you. It was very clear, and you explained it very well. Thank you.
Okay.
I have a question.
Yes.
About thank you first of all, and then is Dr. Husseini finished? I mean,
I think so. You can give your question. Yeah, I think
about
so.
the real-time PCR, the RT-PCR, and that it's not a proof of infectivity.
Yes.
It shows that the virus was there, you know. But you know
yes.
that if you watch, you know, the Ministry of Health or the organizations that are dealing with this with humans, they are following the progress of the virus in the body, and they are releasing patients from the hospitals according to the PCR. So what do you think of that?
Yeah, I think the interpretation of any diagnostic tool or screening tool depends on the context. When you are in the context of human being with clinical science and you have the RT-PCR positive, of sure you have the virus, because it's a question of sensitivity and specificity of the tests. Yeah, the chance that will be a false positive is very, very, very low. You see what I mean? So depending on the context, the interpretation of the RT-PCR will be totally different. If you have one animal without clinical science and you have RT-PCR positive from fecal material, it's
asymptomatic with humans. Disconnected.
Moez, we're not hearing you anymore. If you are hearing now.
They ingest the virus, but there is no infection. So you can see
Asymptomatic.
no, it's not. There's no infection. It's just a passage. It's just a passage of the of the virus. You have the trace of the exposure, not the trace of the infection.
But they say that with humans, they call it like asymptomatic. So
this is different. Yeah, because this is another issue that this is one of the problem. I will send you a nice paper from the veterinary colleague that said if it was an animal disease or an animal pandemic, we'll manage it differently. I think that's when you see the experience of in animal health, we know exactly how to interpret the tests. We know the sensitivity, specificity of the test. We know how to do the interpretation at the population level and at cluster level. And this is something is missing today. That's why we are advocating for the One Health concept. What we learn from animal diseases can be very helpful in such a pandemic situation.
We'd love to have this paper. It's interesting.
Yeah, we sent you the link. The link is very, very, very interesting paper. Okay.
Thank you.
Should we move to the second part?
Would you allow me for comment here?
Yes, please go ahead.
Please, Dr. Hussein.
I don't think that the animal will be infected if you have like a sneeze in a room where there is an animal existing there.
Yeah.
But the animal can, especially in the street, animals like dogs and cats, which is you see them often in Cairo streets, and they go and play in the garbage, especially if the garbage can is open. And if there is any disposal from infected person, the virus will be probably transmitted through their body, like their legs and hair on the animal. And then the animal is moving from place to place, you can carry the virus.
Okay.
Then I think the danger of the animal is not a direct infection of the animal and the animal is sick, but the animal is a carrier for the virus from place to place. If you don't think so, Ruba?
You make a good point here. Yeah, you make.
You see, I think it's like the bottom of when you touch. Do
you know the concept of fomite or no? The fomite. Yeah, this is the concept of transmission of bacteria, virus, whatever it is. And what we are calling fomite, the animals will not represent a reservoir to amplify the virus, but they could be what inert vector. You see what I mean? That like your hands, my hands, when I touch a contaminated surface, I will transport the virus from one place to another one. I think that will play this is the main assumption, the more plausible assumption for the moment, but we don't know because when we observe in some cats, some clinical signs, it could modify this assumption. And perhaps cats and ferrets can play a role, we don't know. So we need to be very humble with the uncertainty today. I cannot tell you for sure there is no problem with animals. Okay, should we move?
Okay, we move to food.
Okay, let's move to food. Okay, so now it's about the food supply chain. So it's about the food contamination may theoretically occur at any place of the food supply chain, at the producer level, at the processor level, wholesalers, retailers, or food professionals. Theoretically, we can introduce the virus at any step of the food supply chain. So we analyzed the two theoretical modes of food contamination. from animals, domestic animals, or from sick person working in the food supply chain. The first mode was excluded because for the moment we don't think that the animals will play a reservoir of the virus, so we exclude this one, we rule it out, and we said if it would not exist, if it exists, the likelihood will be very, very low. So we concentrate ourselves on the handling of food by person infected with this virus. So if we have a sick worker, so what we said, if we are using the good hygiene practice, usually when you have a sick person, a sick worker, they are invited to stay home and to not work. So that depends on the system you need. The recommendation of general hygiene measure is to not handle food if symptoms of gastroenteritis or flu syndrome are present. You recommend to those workers to stay at home or to work at a place without contact with food. But in this context, because of human-to-human transmission, the best decision is that those people should stay home. So if we have asymptomatic forms of COVID-19, this is the problem. So there is the fecal-oral contamination is possible because we observe SARS-CoV-2 RNA in the stool. But to date, no fecal-oral transmission study was conducted. And we, at the beginning, we assumed, so if we have good hygiene practices, we should avoid the contamination of food. But we continue to conduct our analysis, saying how the worker can contaminate the foods. Okay. So for the moment, we need to understand the shedding of the virus by COVID-19 human case. So we know that human-to-human transmission occurs primarily through airborne transmission. We talk a lot about micro droplets. So they can be emitted when the affected person sneezes or coughs. So it can happen in the food plant, but it's usually we can prevent such situation. But something start to complicate the situation because at the beginning we said there's no aerosol transmission, but we have more and more studies going to this direction for the possibility of aerosol transmission. And there's more and more evidence, and that's why the personal equipment for workers are needed to prevent against aerosol transmission. Okay. Second, for people infected with SARS-CoV-2, symptomatic or symptomatic, the virus can be excreted in the stool. This is something that we are offshore, we observe it. The duration of excretion of an affected person, symptomatic or not, may not only last for several weeks, but may also continue while the presence of the virus is no longer detected in the respiratory tracts. So that means after you clean one patient saying you have the test negative, they continue to have RT-PCR positive if stool samples are taken.
Can you?
Yes.
Moez, can you explain more about this point? And I have one question, if you can answer me.
Yes, please.
If I did not really understand the point, so if possible, also my other question is, what I know is that people always ask if they you know, like you said, they tested negative after they've been infected, and they still have the signs, you know, because some people need very longer time to like the throat pain or many things. And they were asking, maybe they started having, when they started maybe for 3 weeks, and then they have some signs, but the test is negative. And they are asking, are we still transmitting the virus or not? Because they want to mix with their families.
Yeah, this is something that we observed recently, some paper. It's well documented, well reported. So for people without no symptoms, and when they do the RT-PCR with the regular sample, when you take sample from the respiratory tract, and the sample was negative, but when in their study, they check for the contamination of stool, and they found RT-PCR positive after the end of the symptoms. So we have different, so in your question, there's different answer. The one I gave to you, and the other one is that when we say 2 weeks or 3 weeks is in average. And so we can have people with longer infectious periods and people with shorter infectious periods. So this is in average. This is the parameter that they are using for the modeling. But now in the reality, you still have variability, and it is very common in some infectious disease that you have people that are shedding they will shed high amount of virus, and they can shed it during a longer period of time. So if I continue here to give you some data about the study. So it's something that we observe with the norovirus. And at the beginning we said, so why we found the RNA in the feces? Is there a digestive form in addition to respiratory form? At the beginning we explained by saying, okay, we can have a respiratory form, you have the viremia, and after we have the viremia, the virus can move to the digestive tract and contaminate the oocytes. This is one assumption. And why we say it, because the spike protein, the one where I showed at the beginning, the one needed to enter to the cells, for the coronavirus, knowing with the digestive tropism, they have this spike protein longer than the one we have with the SARS-CoV-2. Why it is longer and when it is big? Because it helps the virus to resist to different barrier of the digestive tracts. And the S protein is small, and we can say that the tropism, the digestive tropism, is unlikely. But for the moment, all the study are based of the detection of the viral genomes by RT-PCR, and again, does not provide evidence of viral infectivity. And this is a lot of data are needed to have tests that confirm that we can isolate infectious virus from stool to confirm this tropism. So I will go faster because the time is running. So there's a certainty remain about the existence of secondary tropism, and then particularly the possibility of viral infection via the gastrointestinal tract. At the beginning, we said, no way, there's no evidence at all, it cannot happen. But today, we are moving to say we cannot exclude it. You see, because new information coming, because of the uncertainty, we cannot rule it out, but something can be, this way of transmission is possible, but we don't have enough evidence to confirm this way of transmission. So because of that, we said, okay, we have the uncertainty about the infectiosity of the virus through the foods. So the idea now, how could we prevent the exposure? We don't need to, we don't have to wait for the confirmation to do something at the exposure level. So let's see what we can do for the exposure. So for the exposure, we see that for cooked food, there's no problem because the thermal inactivation, we don't have the thermal inactivation for SARS-CoV-2, but when we see with the other viruses, if you cook 40 minutes at 63 degrees Celsius, you can reduce by 4 logs. That means you divide by 10,000 the initial amount of the virus after this cooking at 4 minutes at 63 degrees during 4 minutes. The problem remains for the ready-to-eat foods and food that can be contaminated after being cooked. And this is one of the problems that we are faced too, is how SARS-CoV-2 will survive in the environment. So there is a lot of data saying that it can remain, it can survive 2 weeks after drying. It can survive 5 days at 22, 25 degrees Celsius with the relative humidity between 40 and 50%. But viability will decrease during time at 38 degrees after 24 hours. So we have a lot of data, and I summarize for you this table so you can see for different materials, as you can see here, for metal, clothes, filter, paper, fuel cells, after 5 days, glass, press, paper, 5 days, and so on and so on. So you have different studies, but you have the only one here. The one before are for CoV-1, and this one is for CoV-2. And this is interesting to see that we have data for CoV-2, and they are not very different from CoV-1. And you can see it here, aerosol. You see the decline of the aerosol during time. So it's here is about 2 hours. After 3 hours, you still have in the the virus in the aerosol, in copper, in cardboard. So after 24 hours, stainless steel survive until 24 hours. For plastic is more than 2 days, and so on and so on. So we have a lot of data giving you how. So be careful with that when you communicate with the survivor. This is knowing that the cardboard is contaminated. So we need to add to that the probability, the likelihood. What is the likelihood that the surface is contaminated? You see what I mean? If it is contaminated, it will survive 2 days. But what we can do is not having a contaminated surface. So there's this study, very interesting, the new study with CoV-2, showing that okay, the bad news is that with paper, tissue, wood, and clothes, you see the survival can be sometimes more than 1 day. But the good news is with the disinfectant, you see with 5, 15 minutes, 30 minutes, you can inactivate the virus. So it's not resistant to the majority of the disinfectant. So if you wash the surfaces and you clean them and you sanitize them, yeah, you will eliminate the virus without a problem.
Moez,
So,
Moez,
yes.
I want to ask a question.
Yes, please.
Can I ask a question?
Yes, go ahead, please.
Water? What about the water, the river, for example? I see in the media, French media, that they found the virus in the
Yes.
Seine River. So
Yeah.
Yeah.
For the moment, because we didn't publish the full opinion. We just finished it 2 days before. we found, I said at the beginning, we found the virus in wastewater. So before total treatment. So for some of the water is, we call it non-drinking water that you can use to clean, or you can use it for the agriculture. So you don't have the full water treatment, and we see RT-PCR positive. So this is bad for the moment. When we did the analysis, when you go to the full process of water treatment, I think that will not survive drinking water. If you have a good treatment, there is no problem.
Can we use the question, so can we use the water of the river or water, because you talk about fecal contamination, and we can found some fecal contamination in water and the river. Can we use it, use the water of river for the agriculture?
Yeah, you can. I think it's not a problem because, but after that is only always the same problem. It's not something new with the virus. It's something what we manage with bacteria and virus when we using water from a river. For example, you don't spray the water 2 days before the harvesting, for example. So the same rules will be if you apply the good agriculture practice, you will manage it. It's not a new issue because we have it with the norovirus. Because something that you need to know that because it is an enveloped virus, so it is less resistant than norovirus. So norovirus is more it is more resistant. And if you take the model of norovirus and if your system prevents the contamination by norovirus, you can for sure be comfortable with the SARS-CoV-2. You see what I mean?
I think that the ANSES have done an evaluation about Moez sarf, c'est-à-dire the using of
what you call the sludge, les bouts d'épuration.
What is the conclusion of this?
No, the conclusion for the moment we said we need to be careful because still the treatment is not totally effective, so we cannot spread it everywhere. So we need to be careful for the protection, not for the plants, not for the food that is produced, but at least for the worker. So this is something I will continue with that. The problem today, we are concentrate ourselves on food, but as you can see, the probability of exposure is very low, and if we apply the good hygiene practice, the probability to be exposed through food is very low. However, we need in the and I can show you here for the heat treatment is not something different from the other viruses, and the main problem here is to create an integrated platform keeping employees and community safe, because the problem today is not the food itself, but the fact that we are manipulating. We have people working at the different plants. You can contaminate the food, you can contaminate the surface, and so on. But the main problem is how to protect the employees and how to contact the consumers when they are shopping or not the food itself. Okay.
Yeah. Then we are speaking generally. Because it's not only food, it's anything that is bought or anything that is shopped or anything that is manufactured or in any in any plant or factory. So it's a general.
So that's why when I put it with the food safety system in general. If you
We lost you for a few seconds there. I don't know if you can still hear us.
Should solve the problem.
Yeah, we lost the last part, Moez. If you can.
Okay, I repeat. If you are for sure that the good hygiene practices are well implemented, you see, you solve a big part of the problem. So if you disinfect the surfaces, if you clean them thoroughly, if you cook enough the food and so on and so on, if you take all the good hygiene practice, you can avoid the exposure. Okay, so the exposure through food, we can put it less likely, but the fact the activity is made about the food supply chain, that because that's a human activity in the food supply chain, we need to protect the employees, and we need to protect the consumer when shopping. And I will finish by that. Okay, COVID. We see that COVID-19 will have a long-term impact in consumer, and I think it's something that because I remember 10 years ago when I discussed when we are planning to do some planification of our work in ANSES and food safety in general. So a lot of politicians and a lot of science says, okay, the infectious disease are solved. There's no more problem with infectious disease. And the problem is mainly chemical, and we see that this crisis shows that we need to be very reactive, not only prevent against the identified hazards, but we need to change our paradigm and be more agile in the way that we can react quickly and protect against unknown infectious agents. Okay, and yeah, this is safety for all. This is our dream, is to bring more and more the safety culture in general for all this food supply chain. Okay, any question?
Moez?
Yes.
I have a question. You said that okay, we can have someone that have no symptom, that have negative test, and that have COVID in stool. And for the fecal oral transmission, we have not evidence that it could be possible, but we have no enough evidence to prove it or to say that it's not possible. In fact, it's a big uncertainties issue. But in fact, do you think that after a few months, when the pandemic will be, the outbreak will be finished, that we now our problem is a respiratory contagion. It's contagion between humans. It's respiratory drops that are the problem. Do you think in the future we will have problem with orofecal transmission, and that it will be interesting?
No, I don't think so, because what we are doing today is recall the safety, the need of safety in general, food safety, good practices, and so on. If you continue in this way, we'll have safer and safer foods, because this is for us is a good opportunity to let people know we need to implement this safety everywhere. And for the moment, we can stop the problem of oral and fecal transmission through preventing the exposure if we implement and if we fulfill the good hygiene practices conditions. For me, and I think if that exists, it will be secondary way of transmission, because for the moment we see that is the contagiosity of this virus is mainly due to the respiratory transmission rather to food, to digestive oral fecal transmission. But yeah, the idea is to keep this spirit in mind. This thinking about the more and more safety and be aware about the hygiene and so on and so on.
So a bad thing that is.
This is the big win for me.
In fact, you think that this bad thing is a good thing for food safety? For
everything that people, they start to think about their safety.
Yeah.
Not only that, because when we start, all our risk assessment was done, it is done with the objective to protect the consumers. But at the end of the day, we see that our system should not only protect the consumer, but protect the employees, and this is the vulnerability of the food safety the food supply chain.
Okay, thank you very much.
Excuse me, I have a question.
Go ahead, Ruba.
Hello.
Ruba?
One question is that you've seen the virus in the stool, and there are receptors in the digestive system, which means that the diarrhea we see in some cases is connected with this. Okay.
Yeah.
And another thing with the numbers you've put on the survivor of this virus in the environment, it means that it won't survive more than 48 hours.
This is in average, 48 hours. So that's why I say the likelihood to be exposed is very low. If you have this cardboard contaminated by worker in one step, if from this step to the retailers you spend more than 2 days, you can say the problem is solved. So you have to. But the problem today is people when they are shopping. That's why we give a lot of recommendation to the consumer how to protect themselves during the shopping, and when they buy food, and you see the difficulty. A lot of people, they said we'll put chlorine, we will put we'll wash we will sanitize all the food, and this is the wrong the wrong way to do it.
Of course.
So you need to remind them how to do it and to do it properly. And you see in the US recently they provide some data about the poisoning with the disinfectant. Recently they increased the number of poisoning notification in US because people start using disinfectant everywhere, so they are more and more exposed.
And actually there was also some advice that emerged from some countries, and certainly in Canada actually we've seen some wrongful advice at some point about the necessity of washing every fruit and every vegetable that you buy with chemicals. So, washing them with water and soap, it might be harmless, particularly if you're rinsing the product.
Sure.
But actually washing them with disinfectants and sometimes actually the wrong chemicals, that's essentially what the issue is. And that was unfortunately fueled in some instances by, again, this is one of the issues, by messages on the net. So there's a really a whole slew of misinformation around this, and in particular, the way to handle food in the context of trying to avoid transmission. So, so are there other questions to Dr. Sanaa?
You see, the main precautions we should take, that the food could be a method of contaminant through cross-contamination.
Yeah.
Either from a person or from touching the virus by some way. The virus would not grow in the food,
No way.
but it will stay there with a specific number until we deal with the food.
Okay.
And
Yeah,
I
sure.
don't think there is harm from dealing with fresh food in the right way, not necessarily using chemicals, but for example, what I do for some fruits which have good skin, like orange, for example, I just put it in boiled water for seconds and take it out, and that's what I do for some fruits.
Yeah, if what we said, our recommendation, if you have a recipe that you need to cook the vegetables is okay, but you continue to use your regular recipes. You don't need to cook everything, huh? And you can, you know, the problem is not many what we ingest. Because with the preparation, we eliminate a lot of the virus.
It's what we touch.
Exactly. You see that the one which is concerning me more that we have in certain places in Egypt, they sell the bread is not in package.
And you touch your face. This is the more
it's loose.
problem. Yeah, this is the problem. Not because you are.
This is. I think this is a big problem. That is a very big problem, and we should advise people to put the bread in packages, plastic package,
exactly,
be covered, to be packed, but
exactly
it's not loose. This is one important from your talk. The second one, which is I found it very sign of danger, whether it has been proven or not, which is related again to the stool, which means that more strict hygiene, because for covered people, if somebody gets sick and he was in food processing and he became well and cared and very nice, then he will go back to the work.
Yeah.
But if he's not strictly to good hygiene system, especially after going to the bathrooms, it will still be a source of infection for others.
Mm-hmm. Yeah, but you know,
and again, and if we learn from this crisis to be more and more restricted to apply good hygiene practices in the food chain, on all the steps, I think is for Corona or for others. Who knows what is going to happen tomorrow? But good hygiene, it must be milestone, and we do not get tired from repeating matches and matches on good hygiene, because it is not culture.
Yeah.
And I give you that example for the loose bread, and you see, everybody eat loose bread every day.
Mm-hmm.
Yeah.
And sometimes, you know, when he buy it from the bakery, it is hot. Then he make it cooler by putting it on the floor.
Yeah.
This is danger.
Yes.
And again, I'm a little bit more still concerned about the cross-contamination of dogs and cats, not from being that they are sick, but because they are material to transmit the virus. Yeah. And I have seen that when we had H5N1 in 2006, the rats were a media of transferring the virus from farm to another farm. And the tire of the automobiles were also another vehicle of transmitting the virus from place to place.
Yeah.
Then and we should be careful about cross-contamination more. And disposing, how we dispose masks and rubbers and plastic gloves, how we dispose them. And if we throw them in the normal garbage and the garbage is open and is not well closed, then it is open for cross-contamination again. and be source of transmitting the virus.
So you see that we need a safety culture in general, safety in general, not only safety, food safety, safety in general. And the problem now, do our current system will work well or not? I'm not sure, because our system is based on the system train and pray. You see what I mean? You train people.
Yes,
you train people in one single session, and after that you pray that they will apply them. But we need to have something very different, and we need that we check in real time that all those practices are applied, reinforced, really applied. So I'm working since a few months on artificial intelligence and how to push for more and more data-driven. What we need is to create a new system that will recall the workers what to do daily. You know, everywhere in all our countries, all the workers, they have a smartphone, or let's say if they don't have a smartphone, they have at least one telephone. And you cannot imagine what you can do with SMS. A lot of things, a lot of messages that you can send them. You can use it to have this feedback, this real-time feedback. This is what you are missing, because our system today, when we want to control a plant, say, okay, let's visit them 1 per year or 2 per year, but with the available resources, we cannot achieve that. For some situation, some companies, they are inspected one time each 2 years or 3 years, and we need to find a way how we can have feedback through real-time collection of what's going on in the fields. And this is one of the next challenge, and we need to change the system and use all the available technology, and I think we have a chance that people, they become more and more aware about their safety.
Yes.
That will remember
I agree with
because
you.
when we are talking about food safety, it is for the other. It's not for me. There's numbers. We don't see them. But today, unfortunately, people, they are died with this. They get COVID-19, or because you are at home, you are confined at home. You will remember that. You are at home, you cannot move, you cannot go outside, and so on. I think for the memory of the population, it would be very, very, very useful. And we need to learn from, I think the big win here is that we reached high level of safety awareness. Not only food safety, but safety in general.
This is a magic word, and I think it's a privilege for us to twist the crisis to be a blessing by emphasizing and making use of the lessons that to change our classic way of handling at least food. That's our specialty, and I think it would be a good force for changing the culture, and adhering more for good practices and good hygiene practices.
That's actually,
if we come up with this, I think we would be made use of the crisis to work for us instead of that is working against us.
No, thank you for these, in fact, words that practically constitute a good optimistic message for the end of this intervention. I mean, really using this as an opportunity, really to promote food safety and to propagate that in all our countries. I would like to thank Dr. Moez, Sanaa, and actually the ANSES team for agreeing to be part of this. Last minute, I would say, meeting with the Arab network of food risk analysis. And again, also would like to acknowledge the Arab Food Safety Initiative for Trade Facilitation for enabling this to take place. I would like also to let you know that this meeting has been recorded, and if I do not hear any objection on your part, the recording will be made available after some mild editing to the community of Arab food scientists through the SAFE network. So if you have an objection, I would like to ask you to convey that to me. In the absence of objection, I will consider that to be an acceptance, and the recording will be put on YouTube with an unlisted link.
Okay.
Ruba?
No objection at all from my side. And if Dr. Moez will accept, if the presentation can be shared, I can translate the conclusion of it in Arabic and make it available also for our colleagues in
I will send to Samuel, and you can give both the link to the webinar as well to the documents. No? Okay, so you can do some.
Thank you.
Okay.
Thank you, Dr. Hussein, for volunteering that.
Thank you. Thank you. And very pleased with all the group.
Thank you. Ruba, you had one last point, or your?
It was the same as what Dr. Hussein said. The presentation. Yes, because it has valuable information. I would love to have it available.
Okay.
So thank you, Moez, very much.
Yeah.
Really, thank you. I appreciate all this, and Samuel, of course.
Thank you.
Okay, thank you for having me.
Yes, and we miss you, Karima.
Thank you
Stay
very
safe
much.
and be well, everyone. All the best.
Stay safe, and hope see you soon.
See you soon.
Bye bye.
Bye.
See you soon.
Thank you, Moez.
Bye bye.
Bye
Bye.
bye.
Thank you very much.